Good evening. Is the voice clear? If voice is clear, I will start. No, if voice and display, if both are clear, I will start. Voice and display both. Okay, I will start now. I made the full screen because the gap is removed, because there is some problem for the gap. Quality, I got advanced quality, 480. I should see myself. Is it clear or not? Oh, 1 minute. I will move slightly down because top is not fully visible, I think. Now also you cannot see. Yes, now you can see. Now you can see. Okay. Now, see, last time we established the relation. See, correctly, those who are serious should make all the fair copy. See, I told about last class. Last class, we concluded by writing m by I equal to sigma by y equal to E by R. Correct? I have not given much more explanation. I just got the equation. That's all. I stopped there. Okay, now, correctly see, before going further, y is the distance. Y is from where? Anybody can tell? I already told you, I will give more and more explanation. Little slowly, I will separate the two. See, when you apply for any bending strength or bending stress problem, you take m by I equal to sigma by y. That is called strength part. Whereas m by I equal to E by R, that is called deformation part. Or when you want strength, resisting capacity for bending moment, m by I equal to sigma by y. When you want to find deflection, then m by I equal to E by R. That's why, if you remember, m by EI equal to 1 by R. m by EI. EI is called, if you know, flexural rigidity of the cross section, and 1 by R is the curvature. R is the radius of curvature. 1 by R is called curvature. And later we will prove that 1 by R equal to what? D square y by dx square in the deflection chapter. Then you will get EI d square y by dx square equal to mx. Now, so remember, m by I equal to sigma by y is for strength. m by I equal to E by R is for deformation. Remember, no indeterminate structure can be analyzed without m by I equal to E by R if you are considering within elastic limit. That all will be known later. So, your m by I equal to E by R is the basic equation for analysis of indeterminate structure. And nobody can prove. Sometimes people try to prove with me. Sir, we can do. Okay, let me see how you can do. Something he told. I went back. Finally he told, oh, sorry. Yes, everything originated from M by I equal to E by R. That is for deformation. This all I will give you. And when you want strength, strength means I am shouting class after class. Strength means what? Resisting capacity. How the bending moment is resisted. Then M by I equals sigma by Y. Just now I told, if you see longitudinal view, Y is from neutral layer. But when you take the cross section, Y is from neutral axis and I is about neutral axis. Still we are not proved what? Still we are not proved one thing. What you can tell? Now doubt comes. See, right, where is neutral axis? Where is neutral axis? Across the cross section. I told already, neutral axis comes in the cross section. People telling that neutral layer or neutral plane as neutral axis, they are ignorant of the fact. New axis comes in the cross section. I told repeatedly. Now, doubt. Where is neutral axis? Across the cross section. See, across the cross section. Beam is this way. Across the cross section, where is that neutral axis? Majority are knowing neutral axis passes through centroid of the cross section. Tell yes or no? Neutral axis passes through centroid of the cross section. Just tell me, no. That you are knowing, it is, see, yes, coincides with centroid axis, correct. But is it proved? No. Is it proved? Correct. Stiffness, better. Is it proved now? Is it still proved or suspense? See, yes, correct. It is not yet proved. Neutral axis passes to centroid is still not proved because time up to now we defined only what? Neutral axis. We got the equation. So when you define the bending equation, remember always you have to tell neutral axis. Centroidal neutral axis is centroidal axis is extra information. That is how to locate neutral axis. But once you locate neutral axis, it is called what? Neutral axis only. There is a reason for it. Not now. You will be knowing if you go to pre-test concrete. In pre-test concrete, neutral axis, independently if you consider bending moment and BM due to eccentricity, will be through CG. But when you consider the resultant stress diagram with the axial force, that neutral axis will shift. It will shift from centroid. That shift will be equal to bending moment divided by P. That all you study in pre-test concrete. One pressure line and force line concept is there. So at that time, this information is required for you. Now, I will tell one more information. See, there is a small question I am asking you for those who want to answer. One small question I will ask later. Okay, now, where is neutral axis? Now, what you do is, to know where is neutral axis, you once again go back to derivation. Go back to derivation. Go back to derivation. 1 minute, start. See, don't write again and again. I wrote, consider the cross section. This is bending moment M. If it is sagging BM, upper side compression, lower side tension. Now, you can see, these all we are done in what? In basic theory. Once again I will repeat. Consider a strip of air, elemental strip of area dA, thickness dy, at y from neutral axis. I am not telling centroidal axis, neutral axis. Okay. Now, if you take y, area of the strip is dA, let sigma be the stress at y from neutral axis. Or you can tell sigma is the stress for that elemental strip, area of elemental strip, and epsilon be the strain. General, we already proved earlier, epsilon equal to 1 by r into y. Remember or not? epsilon equal to 1 by r into y. Then I told you something else, epsilon. But you already know that, see, we got epsilon equal to 1 by r into y. Then you also know that stress equal to epsilon strain into Young's modulus. Therefore, what happened? Your stress equal to E by R into Y. Tell me. Y power 1, therefore linear variation. These all I will discuss one by one. Variation across the cross section. See, in this BSK class, I will give more important to behavior, not unnecessary problems or wasted problems. Some imaginary problems are there. I won't waste time. I told you, this is surely not academic class. I will give you correct idea. See how the bending moment is resisted. You will tell internal couple. That all I will consider. So that when you go to RCC, see, same theory used in RCC also. And if I take RCC class, I have to tell them, see, remember this way. I cannot tell this much there. Okay, now. Okay, now, 1 minute further. Now, if I go further, see, sigma equal to E by R into Y, you already got. Therefore, see, this elemental strip will have force. How force? Force will be like this, compression. If I take a strip here, force will be tension. So, if that is in this direction, this is in this direction. Okay, start. Therefore, force in elemental strip, say dF. Why dF actually? It is a force in a very small area equal to whatever stress into area. Nobody can ask, sir, how you got it? Sorry, there is a limit for explaining. Force equal to stress into area is well known. Or we got dF equal to sigma E by R into Y into area or equal to what? Sigma into dA. Substitute E by R into Y into dA. I will write dA into Y. Interchange. This is force in the elemental strip. Tell me. Up to here clear? I will not ask. Why? It was already clear in the last class. Then last class what I did was, see, from here I changed the route. I found moment of this dF about neutral axis. That is dF into y. dF into y are equal to E by R into dA into y into once again y square. This is moment of the resisting force in the elemental strip about neutral axis. Now, there are infinite number of strips are here. Some of them upper side, if the force is this way, lower side this way. If the upper side gives moment like this, lower side also will give moment same way. Don't tell opposite moment. Why? See here, upper side force this way will give this way moment. Lower side this way will give same moment. This I told earlier. Sorry, better not discuss further. Go back to last class. I told you, when you want moment of a couple, you can take moment about any point. Tell yes or no. So we considered moment about neutral axis. So this is for elemental. Now, therefore, algebraic sum of all such resisting moments about neutral axis equal to, I wrote sigma. That will be equal to E by R outside into sigma dA y square. Sigma dA y square is moment of inertia about neutral axis. And algebraic sum of the moment of all these internal resisting forces will be equal to external bending moment M. See, people who tell bending moment is internal because of lack of knowledge. They tell axial force is internal, shear force is internal. I get angry. They are not internal. They are internally, they have internal effect. All section forces are external. I will prove to anybody who comes in front of me. Within 1 minute, he will go back telling, oh, correct. Internally, resistance will come. Yes or no? This I am shouting class after class. 99% people, online class, I am telling, they are telling internal. One fine day, they should learn to rectify their mistake. If they are watching my class, let them rectify the mistake right now only. See, compression, internal. What nonsense is this? Compression is external. Resisting force coming this way is internal. Bending moment is external. Resisting moment coming is internal. I am helpless if they still tell same thing. Even sorry, I do not want to tell reputed institutions in India, they also tell internal. I got a shock. I don't want to comment who. I got a shock when someone who I thought is highly competent or reputed institutes, they also told internal. I want to argue with them. Okay, leave it. Further if I tell, you will tell what? This person thinks too much of myself. Okay, leave it. Now, therefore, you got M by I, see, M by I equal to what? E by R. Earlier we got what? See, sigma by Y equal to E by R. Therefore, equating, we got M by I equal to sigma by Y equal to E by R. See, derivations cannot be by-hearted. I came to derivation blank with only pen. Up to 7:30, I never bothered about this class. I was watching that non-stop fighting going on in TV. Then some debate was there. 7:30, so I thought, now I go back to class. Debate I will watch later. Heated arguments. Only enjoyment. Okay, now, this is already over last time. Now do one thing. For the derivation, when you got what? dF equal to sigma dA or, 1 minute, where is it? Okay. And dF equal to sigma dA or I substitute now, see, dF equal to sigma dA or your dF equal to sigma into dA. Sigma is what? Sigma is E by R into Y into dA. I got this answer. From there I went further. No. You once again come back here. Start. Now don't take moment. Now if you take moment of this force, you get internal resisting moment. Now what you do is take only force. So this much is common. This is force in the elemental string. There, see, there is a element. See, there is a trip here. It has got a force like this. One more element here. It has got a force, say, like this. One more element here. The effect will be tension. Upper side compression this way, lower side tension this way. Therefore, from here deviate. Algebraic sum of, remember, algebraic sum. When it is algebraic sum, direction required or sign required. See, one of the some forces are this way, some forces are this way. Sum of all such forces, all such internal resisting forces equal to sigma of dF equal to sigma of E by R into Y into dA is the answer. Now tell me, this should be equal to what? You should write yourself. See, if some force is acting this way, some force are acting this way, there is no other axial force on the member. See, therefore, this bending theory is only for pure bending. Compression and tension comes, that is perpendicular to cross section. Because of bending, no other force is considered. Therefore, if this is total 100 kilonewton, this also should be 100 kilonewton for equilibrium. Why? Sigma h equal to 0 this way, or sigma along the lengthwise is 0. Therefore, this should be equal to how much? Tell me. Sorry, total force should be 0. Thank you. Should be equal to 0. Why? If some upper side compression means lower side tension. See, this way and this way should be 0. Tell me, this is fully clear? Sigma E by R YdA equal to 0. Is it fully clear? Clear or not? This should be 0. See, force is 0. Moment is not 0. See, common sense. Upper side whatever force this way, lower side same force this way. Force wise 0, but they are equal and opposite. It will create a couple. The couple is already discussed. Internal resisting moment. Yes, okay. Now, see, I will remove this one now. Not required. See. Now, E and R constant. Or you can tell E by R into sigma into dA into Y should be equal to 0. Suppose somebody asks the question, why E by R is constant? I will not tell. I will tell E by R is constant. Why? I already told you. How many times? Go back earlier. I told. There are people sometimes who ask question knowing the answer. I know how to take care of such people. See, E by R dA. Now, I can cut E by R constant, or you can tell sigma dA into Y equal to 0. Remember, Y is from where? Tell me fast. Y is from where? Y is from where? Very important. Y is from where? That is very, very important. Y is from where? Y is from where? From neutral axis. From neutral axis. Now, dA into Y is called moment of the elemental area. Sigma dA into Y is moment of entire area about neutral axis. You can write that is also called as first moment of the area. You can write yourself only, those who are interested. It is called first moment of the area, or equal to AY bar. Correct? Equal to AY bar. Yes or no? Total area into distance of its CG from neutral axis. Total area into distance of CG of entire cross-section area from CG. Tell yes or no? See, A1, Y1, A2, Y2, A3, Y3, A4, Y4 divided by total area. Yes. Now, this is equal to 0. Why? Therefore, what you get? Therefore, AY bar 0 means what? Area can't be 0. Y bar equal to what? Distance of CG of the cross section from neutral axis equal to 0 means what? So Y bar equal to 0 means distance of CG of the cross section from neutral axis equal to 0. What it means? What it means? Y bar 0. Distance of CG of the cross section from neutral axis equal to 0 means what? Center of gravity lies in. It should center of gravity lies in neutral axis, or CG lies in neutral axis, or neutral axis passes to centroid of the cross section. Therefore, neutral axis is also referred as centroidal axis about which bending moment is M. About which, see, if the BM is this way, this is the axis. Fully clear right here. Therefore, neutral axis passes through CG. So, neutral axis is also centroidal axis. Clear or not? Fast tell me. This is in between you deviate. This point clear? Fast. Because I will go something else now. Usually Usually what I do is, after all this one, I will go to basic bending equation. M by I equal to E by R equal to M by I equal, okay, E by R equal to sigma by Y. I can tell whatever way you want. Then I will explain each and every term. Then one strength parameter, one deflection or deformation relation. But what I will do is, I will give some very important information now through an example. See, remember, this example is meant, this example is right here. This example is meant for those people who want to really understand how the resisting moment internally is developed, how it will resist the external bending moment, and very, very important, very important for RCC, both working stress method and limit state method, pre-stress concrete and steel structure, especially plastic theory. There you get what? Where you consider internal part. For RCC, for both working stress method and limit state method, what concept I am using? Only thing is what? In limit state method, linear variation of stress we are not considering. But the principle I am considering is same for RCC. See, when you study RCC, someone would have told you what? Area is B into X, limit state method, working stress method, area, compression, B into X, average stress, FC plus 0 by 2, then passes through 1/3 of X, force in tension steel, AST into FST, passing to CG. So lever arm equal to working stress method D minus X by 3, limit state method, for area equal to B into XU. I can see everything. Average stress 0.36 FCK. CG, it passes through CG of that area at 0.42 XU from where? Extreme compression edge. Tension force 0.87 Fy into AST. Then you write Mu equal to Cu into A or Tu into A. Then you get the equation Mu equal to 0.87 Fy into AST into D into 1 minus AST Fy by BD FCK, or you get 0.36 XU by D into 1 minus 0.42 XU by D into BD square FCK. When you go to plastic analysis, you write same thing there. What? Area A1 stress sigma Y, bottom area other side A2 stress sigma Y, A1 equal to both are equal. You get A1 equal to A2. It is called equal area axis. Then lever arm Y1 bar from there, CG Y1 bar, Y2 bar, total lever arm, final lever arm, Y1 bar plus Y2 bar. Therefore you get MP equal to Fy into Zp, where Zp equal to A by 2 into Y1 bar plus Y2 bar. That is sum of moment of the compression tension area about the neutral axis. Clear? These all basic concepts we are using in RCC, working stress method, limit state method, steel structure in plastic analysis, and also in pre-stress concrete. When you go to strength concept, when you consider the shift of the P force from what? Shift of the thrust line from P line. All that time, what I am telling now, what example I am giving now is very, very important. Tell me, do you want it or not? If you do not want, I will go to equation and continue. For me, no problem. I consider only live people. Live. If you want, I will take up the example. You tell the equation, hey, you wait for some time. It will tell, see, you wrote me, but you have not explained. I will explain 1 minute. Let them first understand the derivation part, how resistance comes. Okay, want it. Therefore, now do one thing, right? One very, very important example. See now, one thing guaranteed, result not tallying. I am risking my profession. When some concepts are there, finally I will tell, answer has to come this much. If that answer is not coming, I am risking my profession. Shall I risk it? Tell past. Shall I risk it? I am risking my profession. What you think? Shall I risk it or not? Not a big issue. I will be risking my profession, not telling I have to stop the classes now. Yes. Okay, thank you. Someone told yes means, that means he got confidence in me. What? Nothing will go wrong. Nothing will go wrong. Let me see which problem has got courage to give different answers. Let me see it. And there is one important question I am going to ask. Small brain teaser. Answer I am not giving. Answer I am not giving. Not required for you also. Let me see who will answer that question. So far, nobody answered that question. All are telling, sir, Kannadadalli, ಗೊತ್ತಾಗ್ತಾ ಇಲ್ಲ ಎಲ್ಲಿದೆ ಸರ್? I am telling, search it. Where? Search it. सर कांटा इला हिंदी. सर कहाँ छुप गया? नहीं दिखता. English. Sir, where hidden? Searching from 1 year, not able to get. Okay, you search and tell later, not now. At the end of this class, I will ask. Once I get the answer. Okay, now be careful. Little fast you have to give the answer. Don't waste time. I will consider a cross section. I will tell repeatedly. I will tell first and last time. When you want stress variation, when you want internal resisting moment, etc., you have to consider cross section. Shouted class after class from past 39 years I am shouting it. Okay. Consider cross section. Consider cross section. Do one thing. I will not take rectangle. If I take rectangle, people are there will tell he took a easy cross section, so he has no courage. Okay, I will take I section. That too, I will not take symmetrical. I will risk. I will take unsymmetrical I section. Right there. Some people will tell, no, it is not called unsymmetrical. It is called asymmetrical. Throw your grammar. I am not bothered about it. I tell symmetrical, unsymmetrical. Asymmetry means it won't come to the mind. I am changing the grammar. I am changing my grammar. Unsymmetry, I am calling unsymmetry. Somebody can comment. Unsymmetry is not correct. Asymmetry. Understood or not? Understood. Keep quiet. Okay. Cross section. See, it is I section this way. Random values. Remember now, purpose is to give very thorough idea. Upper side smaller, lower side bigger I will make. Okay, now, this width is 200 millimeter. This thickness is 20 millimeter. This thickness is 25 millimeter. This width is 250 millimeter. And this thickness is 12 millimeter. Okay, now, the total depth of the beam is 500 millimeter. The question is the cross section figure above is cross section of a beam. Which beam? Which beam? Why should you bother? It is not RCC, that is sure. If it is RCC, tension side concrete you had ignored. That's all secondary of a beam. Cause beam for which bending moment is 1 minute now. I should give a bending moment so that beam can resist it. Okay, why should I bother? Bending moment is 150 kilonewton meter. Suppose the beam fails, we will not bother. I will tell it is a very strong material. It is steel, high strength steel. You don't bother, kilonewton meter. And I will tell sagging. Right. What I want is first I want bending stress distribution. What I want, what is required? Bending stress distribution across the cross section. That is what first I want. Second one I want. Second one you write. Very clearly make the people or those who are going through my class understand how internal resisting moment is developed, which will balance or resist external bending moment M. Clear? I am not writing. Why? Space problem. You write. Make the people who are watching my class or who are learning concept from me. Others I am not bothered. Somebody will tell I am not interested. Then leave the class. Who told you to come? See, very clearly explain and make them familiar permanently how the resisting moment, internal resisting moment is developed, which will balance external bending moment M. You should write it. Okay, start. First, irrespective of one or two, first what you require? First we need what? Need location of neutral axis. You know that neutral axis passes through CG. Actually not CG, centroid, but I told you plane area, lamina, it is called centroid. Center of gravity is for volume. Okay, but in India everywhere, only some countries they use centroid. India we are used to call it center of gravity. Somebody will comment, CG is not for area, it is for weight. I know it. Do you think I am not knowing? But use CG. Say now through CG. Now what you do is write the cross section. First write the cross section this way. Once again write the cross section. All dimensions are millimeter. Remember now, this center of gravity location and moment of inertia, I am not going to explain. People who are learning from me, they should study it. Anyway, this is the only time I will explain that one. Okay, only time. If you are not knowing, learn it now. Okay. All millimeter. This is 200 millimeter. This is 20 millimeter. This is 25 millimeter. This is 250 millimeter. Full depth is 500 millimeter. Anybody can tell me what is this depth first? Anybody can tell me what is this depth first? This depth first. ಇಷ್ಟೊತ್ತು ಬೇಕಾ ಆ ಡೆಪ್ತ್ಗೆ? ಓ ಸೊ 455 ತಪ್ಪು ಕೊಡ್ಬೇಡ. ಆಮೇಲೆ ಇಫ್ ಯು ಗಿವ್ ರಾಂಗ್ ವ್ಯಾಲ್ಯೂ ಮೈ ಪ್ರೊಫೆಷನ್ ಇಸ್ ಎಟ್ ರಿಸ್ಕ್. 455. ನೌ ದಿಸ್ ಥಿಕ್ನೆಸ್ ಈಸ್ 12 millimeter. ನೋಡಿ, ಟು ಲೊಕೇಟ್ CG I will take a reference axis here, bottom edge. See, this is a bottom edge. So I want this y bar, distance of CG of cross section from bottom edge. Bottom edge means that is called y bar. I am measuring y bar this way. This way is y bar. Y bar, that is y bar is given by y bar equal to A1 y1 plus A2 y2 plus A3 y3 divided by total area, or you can tell, okay, today we will do A1 plus A2 plus A3. I bidi parvailla today. But usually I tell divide by total area, or remember this is nothing but total area. Start. Equal to, I write here now. That dimension required, okay, 1 minute. I may forget later because 1 nimisha. 200 by 20, 12 by 455, ಇನ್ನೊಂದು 250 by 25, because I want sketch once again for some reason. Okay, start. Therefore y bar equal to, start here, any one area of this rectangle 250 by 25, 250 by 25 into distance of its center of gravity from here, this distance 25 by 2. I will not ask you clear or not clear. Why? This is not the class for moment of inertia. All the people who want to get more knowledge, right now, you start studying moment of inertia. Start. Area of figure 2, 12 into 455 into distance of its CG from here is this distance, 25 plus half of 455 plus this area 200 into 20 into distance of its CG from here. You can directly do it. How? Don't go this way. From 500, what you do? From 500, subtract half of 20 divided by total area is 250 by 25 plus 12 by 455 plus 200 by 20. Tell me correct answer, accuracy of third decimal. See, because of this accuracy, lastly, if I tell answer has to come 120, you may get 119.9998 or 120.01. If someone tells, see, error came, if he comes in front of me, I will tell him, write endless number. I will tell 1000 digit I want, do it. I can't do it, then keep quiet. I will tell him, you do calculation for 1000 digits, then answer will come. If answer is 120, 119.9999999999999, tomorrow morning also I can tell 999. People, no one will tell that way. Answer. Do not give wrong answer. If you give wrong answer, problem later. Sorry, I told third decimal, you gave only second decimal. No. I told third decimal, you rounded to second decimal. I want more and more accuracy. Because inside this question, hidden part is there. There is a hidden question required for RCC. So far, nobody can give the answer to me. Nobody gave the answer to me. Is it 219.490? After 0 what number? If it is 217.4908, you have tell 491. Check it first. See, if it is 217.4908, you have tell 1. If it is 04, okay. So do not, see, I told rounding off means third decimal. See the fourth decimal and decide. Are you sure 0 is correct? After 0, number is 4 or lesser. Okay, thank you. Because sometimes what happens is, people get 217.498, they will tell 49. Or 4908, they will tell 490. No. When you round off, see next number and decide. Okay. 217.49. Saku, thank you. 217.490 is the answer. Remember, this is red color. Why? This is red color because Y bar. Now, see here. From here to here is, now go back. Eli managalla. Go back and mark neutral axis. This is 25. Tell me, how much further above you have to go? If this is 25, from here you have to go to 217.49. Tell me, how much further above you have to go? From here you have to go by 217.49. Already 25. How much further you have to go? Bega. How much further you have to go? Ittottu beka. How much further you have to go? So beku. Illadre ee question mugiyalla ivattu. If you don't give answer part, this question will take more time. We have to continue tomorrow then. See that today this question is over, if possible. Worst come worst tomorrow. I want to finish today. No reply. 192.4. 1 minute now. What is half of 455? Half of 455 is 200 and... half of 455 is 225.5. Therefore, you should not go up to here, little down. Clear now? It will not come up to center here, up to here only. somewhere here is your neutral axis. Now, this distance is, I will use a red color now. Actually, one dark red required, so that it is fully crystal clear. Same. I won't get today. I won't get it because I need a red color pen. Now, the pen box is telling, you want it? Okay, then I am not coming. Then I won't come. It is the usual. If you want something, you won't get. Okay, let me see. This is same pen. Same one. Ink bottle also is not there. Okay, leave it. Yes, so much of here. Yes, got it. This is, got it. 217.49. Sakbidi. 49. Children, beta. Tell me. See, actually third decimal, 0 not required. Tell me, what is this distance? This is neutral axis. See, individual CGs are here. This is CG of the upper top rectangle. CG of the middle rectangle, that is called web. This is CG of the bottom rectangle, that is called bottom plane. Tell me this distance, fast. From 500, subtract it. From 500, subtract it. Little fast. Tumba time waste ಆಗ್ತಾ ಇದೆ. 282.51. This is 282.51. Okay. Now we got correctly location of CG or neutral axis located. Okay. I am removing this one now. Not required for me. Okay. Now start. Now right here we located neutral axis. This is 500. Okay. Now we need 500. Now you need moment of inertia of entire cross section, that I section, about neutral axis. That is I about neutral axis. Get the answer in 10 to the power 6 millimeter power 4. Big number. 10 to the power 6 millimeter power 4. Get moment of inertia of the entire cross section in 10 to the power 6 millimeter power 4. I got moment of inertia 661 point, I wanted more accuracy, 0 to 498. Actually 49777 10 to the power 6, or I can tell approximately 661.02. 61.02. Okay, such a small number is okay. 025 into 10 to the power 6 millimeter power 4. 1 minute. I am non-stop talking for nearly 1 hour and high pitch voice. So I will take a small break, not a break. By that time, those who know get moment of inertia. Okay, show talent. If you are not knowing, I will briefly explain here, very briefly. But time will not be wasted. Why? Calculation you confirm. If number is correct, or I may proceed further. I may explain that one next time. I will see that also. But first confirm that moment of inertia is correct. Maximum 2-3 minutes. I will sit here and come back. I need little rest for non-stop talking. First confirm that moment of inertia is correct. Okay. Because so many are knowing about it. Because if wrong, it will create problems later. If wrong, it will give problem for me. Okay, I am outside the room, one replies same correct. Still, I will take 2 minutes break. Okay, others try it now. At least try and try to get the answer. There's a comment, someone told, checked second time, getting 668.025. See, not 25 is there here also. So, I do not want to take a chance. If you are losing for 2 minutes, no problem. It is not a big issue. If it is losing, suppose you cannot complete, no problem. Time is there. I do not want error. I will check once again. 217.49 plus 282.51 is 500, correct? Okay. I will tell here explanation if you want, not today. When I go to numerical part later, when I take unsymmetrical dissection, I will explain once again. Okay? Not today, because today I want to go further. Because this is not Untitled chapter, this is center of gravity, engineering mechanics. So what I will do is, I will now proceed further with the answer. Some answer check once again. But if you want anybody who finds difficulty, wait for some time. As I go to more explanation, I will take unsymmetrical dissection. There, I will explain moment of inertia. Then you come back here and get it. Or those who want, leave half page gap here. Leave half page gap. You fill up the gap after another 2 classes, not now. After 2 more classes, you fill up the gap. Time being, time counts. So I cannot go further. Where is the pen I kept? Same problem. Sometimes, here. Idella. Sometimes this misplacing will give a lot of trouble. Okay. Okay, not this one. I was having with me, I placed it somewhere, now not getting it. Usual problem. It is not first time. It is not first time, it is permanent effect. Where I kept it? Hi. I filled the ink for that one and it is beautifully writing red color. Okay, this one the 1 minute. No, this is blue color. Okay, I will go to blue color now. Color change because that which I was using, I kept it somewhere now. See, that always happens with me. I don't know why. Okay, start. Okay, I will check once again. But I will tell you if you want. See, 250 into 25 cube divided by 12 plus 250 into 25 into 217.39 minus half of 25. That whole square. That is I for this one, middle one, plus 12 into 455 cube divided by 12 plus 12 into 455 is the area into what I will do is 25 plus 455 by 2 and subtract 217.49, that number to be squared over. Last one plus 200 into 20 cube divided by 12 plus 200 into 20 is the area into 282.51 minus half of 20 is 10, that number to be squared. Divide by 10 to the power 6. I got 660.7688. What is happening? Now I am getting 660. What is the problem? Calculator problem. It is called. What is the number you told? Number 668. I first time got 661. Second time I got 660.7. I will throw the calculator outside. If it happens once again. 250 into 25 cube divided by 12. Calculator problem. Plus 250 into 25 into 217.39. Sorry, 217.49. 49 minus 12.5. Okay. Close square. Plus 12 into 455. Last time I am doing. Cube divided by 12 plus 12 into 455 into 217.49 49. I will remove the other distance, minus 25 minus 455 by 2. No problem. Both are same. Close. Square. Plus 200 into 20 cube divided by 12. Plus 200 into 20 into 282.51 minus 10. That number to be square. I am getting once again 661. So my calculation is correct. Usually moment of inertia I don't make mistake. So my answer is correct, 661. So I will continue with my answer only. No, not 668. I once again got 661 only. 661 divided by 10 to the power 6. 661.025. Okay. I will continue with my answer. See. Yes, thank you. Now, see. Now, first part is to draw bending stress diagram. Remember, sorry, I have not put the mic on. Okay, no problem. Wait, this was actually checking purpose. Mic not required. But still you can hear the voices. Okay, now I put the mic. You remind me when I take the break. If I don't put the mic, always remind. Okay, now. I over. After this example is over, I will very, very thoroughly explain the bending stress distribution with a lot of concept. Therefore, if my purpose is to give some knowledge for you, so therefore, if someone finds difficulty, see not fully clear, wait for 2-3 classes, then come back. Okay, now, bending moment is sagging. I lost that black colored pen only. See, maybe placed somewhere, now not able to get it. Okay, leave it. Who will struggle now? This actually upsets. Such a easy to place somewhere, I placed, not getting it. Okay, sagging. This is neutral layer. Lower side tension, upper side compression. Therefore, your bending stress distribution across the cross section is, see, if I take the cross section here, I will write once again now. This color is really creating a problem for me. Is if the neutral axis comes here, you know this distance is to 282.51 here, and this distance is 217.49 millimeter. Then if I draw the bending stress diagram, remember, even if I write here, the stresses are acting perpendicular to cross section. Told thousands of times. It is maximum compression here and maximum tension here. What I usually do is, in my class for bending stress, what I will do is, I will take topmost fiber as F1, not F1, sigma 1. Sigma 1, topmost fiber. Bottommost fiber, sigma 2. This I will call Y1, this I will call Y2. Compression, tension. Remember, compression, tension are perpendicular to cross section. Now, general equation. In general, M by I equal to sigma by Y, or sigma anywhere at Y from neutral axis, M by I into Y. Your bending moment is, I forgot the bending moment only. Tell the bending moment I told. I can change it also. How much bending moment I told? I completely forgot. In the question in the beginning, I told bending moment. Anybody can tell? 150. Bending moment is 150 kilonewton meter. No. When you want to see, Y is in millimeter. Distances are in millimeter. Moment of inertia is in millimeter power 4. I want this bending moment in 10 to the power in Newton millimeter. This all are knowing. Okay. Now in general, therefore, stress at the topmost fiber, sigma 1 equal to M by I into Y1. Stress at bottom fiber equal to M by I into Y2. If I continue this one, 150 10 to the power 6 divided by I, come here, 661.025 10 to the power 6 into y1 is 282.51. Answer I require. This is 150 10 to the power 6 divided by 661.025 10 to the power 6 into y2 is 217.49. Tell the value in up to third decimal. Both are in Newton per mm square. Both will be Newton per mm square. Tell correctly up to third decimal. If you get some number third decimal, see the fourth decimal and tell me. Because I want accuracy. Or do one thing. Only for this question, give the answer fourth decimal. I want more accuracy. Only for this question, give the answer up to fourth decimal accuracy. Where I placed that black color pen? Sometimes see, it is, I filled full ink there for the class. Now, not able to get it. Sometimes become frustrating. Little misplacing. Where I don't know. Okay. Tell the answer up to fourth decimal accuracy. How much? You are not giving answer. So, I have to calculate myself only. See, no cooperation from you. Is it 64.1073 up to third, fourth decimal? Other one is 49.3528. Tell me, are these two numbers correct? I will continue with the black color pen, which is not fully writing. Okay. Visible means okay. Okay, visible. In right, 1 minute now. I think I placed it outside. I went there, maybe it's outside. Because it is actually right with full shiny. 1 minute. Got it? Tell me, is the answer correct or wrong? Today we may take little more time so that we'll complete the question. Try to complete. Correct? Okay. Now, remember now, whenever variation is linear, to draw the diagram, we need only extreme values. Intermediate values are not required. Intermediate values are required if parabolic variation or we got what? Variation of higher power. Linear variation you can find anywhere later by either what? Similar triangles or substitute. Basic definition is what? When linear variation is there, we need only extreme fiber. Okay, now, remember now, we are going to more details. Therefore, I will enter here. This is 64.1073 Newton per mm square. This is sigma 2 equal to 49.3528 Newton per mm square. This is bending stress distribution across the cross section when the cross section is subjected to. By the word only you can make out. Same people who tell bending moment internal, do you know what they will tell? When the cross section is subjected to. When they use the word, when the cross section is subjected to. Tell me, internal or external? When you tell cross section is subjected to, what is the meaning? Internal or external? By word only they can make out. They will tell when cross section is subjected to. Means what? Internal or external? That word only will tell you. Subjected to bending moment of 150 kilonewton meter sagging. Okay, now remember, one part of the question is over. Clear now? One part of question is over. Bending stress diagram we completed. Now we want to go understand how that internal resisting moment will come, which will balance external bending moment M. See, 1 minute. I will once again put the cross section. I wrote somewhere and rubbed it. Now you have to tell. Nothing can be done. I noted down somewhere and rubbed it. Okay. Now once again consider cross section with the stress distribution. See, this is second part. I told you second part. Only for those who are interested in learning more and more. Others can leave the class right now. Suppose you tell, sir, these are all not required for me. Right now leave the class. Okay. Little fast you tell. This is 200. I will write dimensions here. This is this is 20 millimeter, all in millimeter. This is 455 millimeter. This is 25 millimeter. I remember still. This is 250 millimeter. This is 12 millimeter. And now I do not want CG actually. I want only neutral axis. And see, now I want red color. I won't get it. I got it. This is the neutral axis, little out of scale, neutral axis. And one more thing now. Now I do not want 455. For some reason, I want neutral axis from here. This is 282.51 millimeter. This is 217.49 millimeter. And this distance you give splitwise. Tell the answer. The middle portion from 282.51 subtract 20 to 62.51 millimeter. This is from 217.49 subtract 25. You are not giving answer. See, you are wasting my time because you are not responding. Is 192.49 and corresponding bend. This is this one. Corresponding bending stress diagram is when the cross section is subjected to what? Subjected to a sagging BM. This is compression. How much? 64.1073. All values are in Newton per mm square. You write here. This is bending stress distribution across the cross section. Here tension, I will put other way, passes to neutral axis. It will be like this. Okay. This is Now, remember now, note, all these are perpendicular to cross section. Now see what I am doing. For some reason, I want this value and also I want this value. You should, those who are serious, they should calculate. I am not putting direct answer. What you can do is, you can write 64.1073 divided by 282.51 into 262.51. From similar triangles, you can get it. Or you can use the same equation, m by I equal to f by y or sigma by y, or this test equal to, use y equal to how much, tell me? Substitute y equal to how much? If I want stress here, substitute y equal to, answer. First, if I want stress here, substitute y equal to, this is your choice. How much? Y equal to, that 262.51 is y equal to 262.51. Either you use the bending equation, see, sigma equal to m by I into y, m is known, I is known. For extreme fiber, you put 282.51. Put y equal to, you write a note. There is no place right here. I am giving concept. Little effort from you should write. Let this stress is sigma dash. sigma 1 dash. You call sigma 1 dash. This you call sigma 2 dash. To get sigma 1 dash, either use similar triangle property because linear variation, or basic equation, put y equal to 262.51. Answer. Answer first. Is it 59.5689? Is it, see, you are not giving any answer. Is it 59 point, see, forgot. 5688 Allah. See, 56885 is there. So 5689. I want correct accuracy. 5689, all are in Newton per mm square. This value equal to, you can do whatever you want. See, m 150 divided by I 661.025 into y substitute 192.49. It is 43.6799. 43.6799. Correct? 43.6799. This is how much? 49.3528 is, remember now, this is the stress diagram for the upper flange. This is the stress diagram for the web which is above neutral axis. This is stress diagram for the web below neutral axis. This is the stress diagram for the lower flange. Tell me, fully clear or not? Fast you have to tell. See, time is not there. I want to close today, if possible. 10 minutes more I will take. Yes, okay. Now, some statements, those who are serious should write some statements. See, these statements, I will see, this, the purpose of this question is knowledge or understanding. Therefore, what all I dictate, you have to write. Okay. Now, I told so many times, stress is acting perpendicular to cross section. It is not this way. So, if I write one more sketch here, see, I will write force diagram. See. Now, everything is from this side. See, this is, red color bada, this is force diagram. I will not write like this. See, so many people, they write like this. They will tell upper side is getting compressed. See here. Upper side getting compressed. It is a force diagram. Force due to stress. Due to stress. This way. They will put lower side this way. Actually, this is wrong. That is compression. Tell what this looks like. That is compression. This is actually, this also looks like what? Tell me. This also looks like. That is compression. This also looks like what? Tell me. This also looks like. When you draw the stress diagram, you draw. But actually, I told you, this should be that side. Compression. So, correct principle is to understand this is compression. What you do is, here, from here to here, you write this side. See, this way. This is tension. Now clear? This is tension. How much here? This is tension. Clear or not? Now, this junction is very important. This junction. I will use blue color for the junction. See, use blue color for the junction. Blue color for the junction here. Blue color for the junction. Now see, what, see, now, this is the red beda. That is the force acting on upper flange. This is force acting on web here. This is force acting on bottom side. This is force acting on the bottom one. Now see, this force I will take only this much. Only this much. Then I will separate this one. See now, I will take this much. For this one, resultant force will act here. I will call this as C1, not C1. 1, 2 means something else. Okay, C1 dash means what? C1 dash means the force coming due to bending, compression on this area. You should know some formula. Force equal to stress into area. Yes or no? Fast. Fast, tell me, no time. You have to finish today. Force equal to stress into... Those who are serious, write everything. People who don't write everything, let them not come to the class. Force equal to stress into area. Yes, but remember, when the stress is varying, force equal to what? Remember, when stress is varying, resultant force equal to average stress into area. Tell me, are you using in RCC this one? Tell me, are you using this in RCC or not? First, this principle, are you using in RCC or not? Average stress into area. First, see, no answer. In RCC, BXFC by 2. Yes. Therefore, remember, right here, you should write C1 dash equal to average. You should write average stress for this portion is 64.1073 plus 59.5689 divided by 2 is the average stress multiplied by area equal to illi. Area means contact area, cross sectional area. 200 by 20. 200 by 20. Tell fast this answer in 10 to the power 3 Newton. Fast this answer in 10 to the power 3 Newton. I want 4 decimal accuracy. 10 to the power 3 Newton. You are not giving. I should calculate. Is it 247.3524? 247 point. It is 247 point. See, once again problem. I got 3524. Okay. 3524. 3524 10 to the power 3 Newton. And see, now I want this distance. This distance is the resultant force will pass through CG of this stress diagram because area is uniformly spread. This distance of CG from here equal to this side 64.1073 plus twice of 59.5689 divided by 64.1073 plus 59.5689 into 20 divided by 3. You should know that one, or this will be equal to A plus 2B by A. If I want CG from here, this side plus twice of this side divided by this side plus this side into distance between them divided by 3. Give the answer, please, little less than 10 mm. 4 decimal. Give the answer little less than 10. Why? Because midpoint is 10. It will slightly shift up and right. Again, no answer. See, nobody is helping me. I have to tell everything and calculate also myself only. You are giving lot of trouble. I am doing slowly because I do not want error. 9.8777. Now you are telling when I don't want it. See, still nobody answered. See, That means you are determined. Let him only struggle. Are you determined that way? Let him struggle. Why should you help him? 9.8777. This is called no cooperation. 9.8777 millimeter. And same way through this CGC, this one, there is one more force here. I will call it as C2 dash. C2 dash. And C2 dash will pass through CG of this triangle, which will be from here 1 by 3 of this triangle. How much? 262.51. Tell the answer. 1/3 of 262.51. It is 87.5033. 87.5033 millimeter. And your C2 dash equal to, see, for this portion, stress is 59 here, 0 here. Average stress 59.5689 plus 0 divided by 2 is the average stress into this area. 12 into area. This is the average stress into 12 into 262.51. Answer fast. Answer. ಇಲ್ಲ ನೀವು ಕೊಡೋದ ಅರ್ಧ ಗಂಟೆ ಆದ್ಮೇಲೆ ಕೊಡ್ತೀರಾ. .8246 10 to the power 3 Newton. Is it fully correct? Fast. Okay, now do one thing. You have wasted lot of time by no cooperation. When I asked value, you are not giving. At right there, keep the pen here, flip the calculator, struggle and write. This is called very bad response. Now therefore, I cannot continue. Now what you have to do is, I will not explain. Same way, for this one, there is a force here. See, that is compression. One tension force, I will call T1 dash. One more, for this triangle, again a tension force, I will call T2 dash. See, this will act through CG of this trapezium. See, this trapezium. That, and T1 dash equal to this average stress into this area. Now you should try. I will give you the answer. You try and tell correct or not. $3528 plus, oh, this number only rubbed out. Who knows that? Okay, now again I calculate. 150 10 to the power 6 divided by, I forgot moment of show now. Abba. 661.025 into 192.49 is 43.6799. 6799. Okay. Now you calculate this force equal to this average stress. Sum of these two divided by 2 is the average stress into area is this area. You should do it. 49.35. Remember. Is the answer 290.72 10 to the power 3 Newton. Is the answer correct or wrong? Fast tell me. 290. Yes. And this distance is from here. From here I want. 49, you should write 49.3528 plus twice of 43.6799 divided by 49.3528 plus 43.6799 answer into 1 into 25 divided by 3. It should give divided by 3. It should give slightly less than 12.5. 12.24 this distance. 12.2459 millimeter. Correct? Anybody got it? 12.2459. Anyone got? Fast, tell me. 12.2459. Anybody got? Yes. And the second force is this average stress into this area. That is 0 plus 43.6799 and then by 2 is the average stress into area is 192.49 into 12. Is that answer 50.4477? 50.4477 10 to the power 3 Newton. Correct? 50.4477. See, nobody answers. See, if you don't give this answer this way, what I can do? How much I should struggle? This is a concept I am telling you. You are not cooperating. 50.44777. Allu Chaukas, you know. And now, this distance from here will be from here 1/3. 1/3 of what? 1/3 of 192.49. That will be 64.1633. 64.1630. Answer ಕೊಡ್ತಾ ಇಲ್ಲ ನೀವು. You are not giving any answer. 64. ಎಲ್ಲ ಅರ್ಧ ಗಂಟೆ ಆದಮೇಲೆ 1633 millimeter. 1633 millimeter. Okay. Now, what I will do is, next time I won't explain. I will now write, continue from here, continue here, no space. I will come back here, this diagram or this test diagram or this cross section, I will remove. Now, someone has to help me. What all on the board? I want a screenshot now, right now. Can anybody take a screenshot? Fast. Anybody can take a screenshot? Fast, tell me. I want right now. Because later difficulty. Anybody can take a screenshot? Take the screenshot right now and send it to me in the group or personal number. Nobody's agreeing. Because I am rubbing now. Take a screenshot and send it to me in the group or personal number. Okay? Taken. Okay, send it to me. Now, little powerful concept now. See now. I am reviewing this one. Remember now, if I tell C1 dash, it is force in this upper flange. If I tell C2 dash, it is force in the web which is above neutral axis. Both of them are compression. If I tell T1 dash, it is force in the bottom flange. If I take T2 dash, it is force in this portion which is above the junction up to web, up to neutral axis. Now, those C1 dash, C2 dash are acting. See, I am doing one thing now. If I hit the board will get smashed. See, I'll show you. If the same section is here, okay, minute. If the same section is here, C1 dash and C2 dash are acting this way. T1 dash and T dash are acting this way. Perpendicular to the cross section. Full clear? Fast. Full clear or not? Okay. Now, already time over. Do me a favor. You add the C1 dash and C2 dash and add T1 dash and T2 dash. If the answer is different, from tomorrow no class. Do one thing. Add C1 dash C2 dash. Add T1 dash T2 dash. If the answer is not telling, my profession at risk, I will stop my teaching forever. Tell the answer. Fast. Don't tell same. You add the two C1, add the two compression force, add the two tension force. Both of them should be same. If they are not same, from tomorrow there will be no class for anybody in future. Case that will stop the teaching. You can write, my class will get over, closed. Tell me, fast answer, check it. Check it fast. Tell me, check the value. Add the two compression forces, add the two tension forces. Both of them should give same answer. 1 paisa, 2 paisa, no problem. You are not answering. Tell me, same or not? I want same or not. Internal couple, I will come next time. Internal couple, I will explain next time. Internal resisting couple in my class has to come 150 kilonewton meter. Otherwise, again I will stop my class. See, no comment, nothing. Are both sum of the two compression forces, is it equal to sum of the two tension forces? Nobody is giving answer. Don't worry. My class will not stop. Nothing to worry. If answer is not telling, only reason is calculation mistake. Only chance is calculation mistake. Oh, thank you. Finally, someone told, oh, I am not. See, I am seeing the comment in this box. I is correct. Oh, equal. Okay, thank you. At least, now getting confidence, tell me. If you got equal, at least are you getting confidence that this person at least knows something? See, you should get confidence. You should tell someone that person who is teaching us, at least he knows something. Yes, okay. I will continue tomorrow. I will show you the internal couple, how it is resisted. I will give analogy to RCC if requirement is there. Otherwise not required. Tell me. I will give analogy to RCC and then ask you that tricky question which so far nobody could give answer. In my 39 years, not a single person could give answer for that one. Okay, thank you. See you tomorrow. Don't forget to send the screenshot. I told you. Do not forget to send the screenshot to me. Okay. Not for checking purpose. Just for writing next time. I am not going to check. I got confidence.